All right, so audio check. Can you hear my voice? Check, 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 check. Can you hear me? Cool. And can you see my computer screen? All right, so what I'm going to do is I'm going to teach you statistics this time around, and we're going to get through this as quickly as possible. We might get through this entire chapter just today's lecture. So keep up, and basically I'm going to teach you statistics using a spreadsheet of some sort. You guys can use whatever spreadsheet you want. I would recommend Google Spreadsheet. It's pretty standard across the board, but if you're old school, you might want to use Excel, which is pretty much the same thing. We're going to teach you to make statistics, and so let's see. Statistics is all around you, and without even realizing it, you probably use statistics every week. I'm actually going to be taking a statistics course for in engineering as a part of a degree that I'm trying to pursue. And what's really interesting is I've never actually taken a course in statistics, not in high school, not in college, not anywhere. But I did start to take a first-year statistics course. This was like 2 years ago, I think it was. Yeah. I started to take a first-year statistics course, and they tested me out of it. They said, you shouldn't take this course because it's too easy for you. And I was like, what are you talking about? And they were like, well, you're already good at all of this stuff. And I mean, I'm not trying to be all high maka and everything, but like, what they're saying is basically, you already know how to do this stuff. And I was like, well, this is all stuff that makes sense to me. I guess it's because I've taken so much mathematics over the course of my degree as a physics major that they basically said, oh, you already know all this stuff because you learned it when you were doing labs. And so what I'm teaching you guys is going to be relevant to you if you're going into a science, or actually if you're going into anything, really, because I found this to be very helpful to me later on when I was doing like science labs and stuff like that. So anyway, let's do statistics. To me, it makes sense, so I hope I'm not skipping over things, but let's jump into it. The first thing I want to introduce to you is a dot plot. It's pretty straightforward. They're going to give you a set of numbers, and I typed up the numbers over here. So 2, 3, 5, 6, blah, 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 blah. And what they did was, this numbers seems really unorganized. So what they want to do is they want to see, well, how many 2s are there, and how many 3s are there, and how many 4s and 5s and 6s. You know what I mean? Yes, no, hello, are you guys there? Say, oh, okay, or yes, good. All right. So what I did was I pulled up a Google spreadsheet and I just typed in the numbers here. And then I want you guys to be able to learn how to do this with spreadsheets, because this is going to be very helpful to you, is you can basically sort it. You can say, I want to sort from A to Z or whatever. You know, it's interesting. I don't think I have the ability to edit this document. I might have to log in to here. Let me. Try. Close that out. Go to Chrome. Sorry, give it a second. I just got to switch to Google Drive on my personal account. There we go. Algebra 2 stats. That should log me in, and then I can edit this. Awesome. This one. All right, so the first thing I did was I plugged in all the numbers over here. Now you can have it sort the data for you. You basically just click on this thing right here, or highlight the the things you want, and then go to Data and Sort A to Z. And basically it just means sort from smallest to biggest, and also alphabetically. Huh, that's really weird. I wonder why it did that. Alright, so I sorted it from A to Z, and what I found is really weird is why did it change how the graph looks? It shouldn't have done that. Anyway, let me think. Why did it change the graph? I want you to sort this data, A to Z. Why did it put... Okay, wait, let me look at this. I think I know what's going on. I'm sorry. How embarrassing. Tell you what, why don't I just delete this graph and we can see exactly what to do. Alright, here we go. Delete chart. Alright. So the first thing I want to do is I want to sort it out alphabetically. So let's just sort it. Data, sort, spreadsheet. There we go. The trippy thing that it's doing for me is I don't know why it's pulling this data and putting it down here. Because if you noticed, when I highlighted it, I didn't highlight the word data. I just said skip that thing. Alright, let me do this. I'm going to delete this thing. Actually, I know what I'm going to do. I'm going to pull this thing down so it kind of locks in this first row right here. Now I'm going to spread it, or sort it. I'm going to see what happens there. There we go. Alright, I sorted the spreadsheet into order. So, how many ones are there? There's 1, 2. There's 2 of them. How many 2s are there? There's 1, 2, 3, 4 of them. How many 3s are there? And so on and so forth. So we can count them. Cool? Now, we want to use this in a dot plot. And the way you can do that is you would put a number line and you would actually write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or whatever. And you would put dots as how many, you would put 2 dots for the number 1 because there's 2 number 1s here. I can have the spreadsheet make this graph for me really easy. I think that the one I used was, let's go to Insert and Chart. And this thing is called a column over here. I think this is called a histogram right here. Insert that. And then what I want is, basically it's saying you have certain size bins. And I guess the question that it's asking is, how many numbers are in between the numbers 1 or between 0 and 2? There's actually 1, 2, 3, 4, 5, 6 of them. Oh, no. There's 2 numbers between the numbers 0 and 2, not including 2. There's 1, 2, so that's why there's 2. That number 2 over there. And then how many numbers between the numbers 2 and 4, not including 4. So you count that many, and that's how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why that number's 10. But that's not what I want. I want a bin for each number. Did I make sense? Did that come through clearly? Hello? Alright. So what I want is kind of a bin for each number. I don't want a bin for 2 numbers. So I'm going to go to Advanced Edit. And I'm going to set this thing up to be bucket size. I'm going to say I want the bucket size to be 1 unit. There we go. So that's exactly what I want. And then I think I'm going to do the little dividers to kind of help me out with that. And you can change the properties to make this thing look prettier. But that's pretty much my graph right there. That's what I wanted. We cool? So that's kind of, I guess this is my way of doing a dot plot on using Google Spreadsheet. Because, I mean, I think the only difference is there's dots over here as opposed to the other one. You guys understand a dot plot? But the nice thing about the way you look at these things is, like, let's say that this is the certain number of hours that a student spends on Facebook or Instagram each day. So the nice thing is when you organize the data like this, you can easily see and answer questions that they ask you, like what is the greatest number of hours that a high school student spends on Facebook? So you guys tell me, what's the greatest number of hours? Looking at this chart. That's a question I'm asking you. You guys are typing in the answer now. And you're pressing enter. 9. Awesome. Cool. I mean, I guess you could look it up over here in this chart right here, and you see a 9 right there. By the way, even though this one looks like it's between 9 and 10, what you call it, the cell goes with that number to the left of it. So this is 2 8s. There are 3 6s. There's no 7s. There's 4 5s. You know, I set it up on this table to help me see it better. But yeah, 9, absolutely. What's the least amount of numbers that a high school student spends on Facebook or Instagram each day? Seven. No, no. That's the least amount of students. Or that's the number of hours the least amount of students has. That's the number of hours that has the least amount of students. Blah. What is the least amount of hours? One. There we go. What's sad about it is it's not 0. I mean, I don't spend any hours on Facebook or Instagram each week or each... I don't even have... Like, I have a Facebook that I haven't used for like 4 years, I think. But then again, Mr. Dalday's a nerd and one of those socially awkward people, so maybe that's why. I don't even have an Instagram account. I don't even know how to use one. Whatever. Anyway, what is the frequency of data entry of 6 hours? So, like, how often do we come across a student who, who uses it for 6 hours? I'm asking this question here. Please tell me the answer. Look at the data. Come on, we got to get through this quick. I know this is cake stuff, but I mean... Hello? You guys there? Oh, you don't need to look at the data. Look at the table. Look at the table. That's the point, is once you make the table, you can easily see the data. Can you see my screen? Well, I'm sorry, not table, but the chart, the graph. Look at the graph. This thing right here. Look. If I'm asking you for 6 hours, you go to, okay, well, here's 6 hours. How often does that 6 hours appear? Well, 1, 2, 3 times. Huh. Your screen can't see my screen. Your screen should be able to see it. It's popping up on mine. Sorry, Erica. I mean, I don't mean to put you guys all on the spot, but I'm just saying. Can everyone else see my screen, or is everyone else having problems? Savannah. Actually, who else is here? Kaylin. Savannah. So if I ask you how often does a student appear for 6 hours, that you would say, oh, okay, 1, 2, 3. That's how often. There's three of them. 1, 2, 3 sets right there. We good? All right, next question. What is the greatest frequency? This is the question I'm asking. What is the greatest frequency? Which data set has the greatest amount of frequency? You don't know. Oh, okay. Well, hey, Savannah, I appreciate you saying I don't know. At least that means you can hear me. I don't know if Kaylin can hear me. I don't even know if Erica's back. But what you do is you look at, okay, well, which piece of data has the greatest amount of dots next to it? And what I mean by dots is I mean these little cube things. I know they're not dots, but I mean, bear with me. So which one has the highest stack? 3. Yeah, exactly. And that basically, you can immediately, once you see the chart or the data plot, the dot plot, you can immediately say, oh, 3 hours. 3 hours has the most amount of students. I'm sorry. You know what I should put is I should put a title and maybe some labels on here. Let's see. This is the number of hours a randomly selected high school student spent on Facebook or Instagram. Okay, so this is hours for Facebook or Instagram. All right, this measurement is the hours. And then this is the number of students. There we go. So I made little labels for this thing. Let's get rid of this legend. I don't want to know. All right. Are we cool with that? So this is the number of hours, and this is the number of students, and I made a little table with that. And anyone have any questions about how to make the table? Anyone have any questions about how to read the table? I guess that's another good question. All right, then let's try this one. Okay, let's look at this dot plot. And this is their way of doing it. And I don't know how to change these squares into dots, but basically mine looks the same. The only difference is my dots are a little bit shifted off to the right a little bit, and those dots are straight over the number. But this is officially how you make a dot plot. I just don't know how to do it, nor do I think that Excel or Google can actually do straight up dot plots. I just thought that this would be the quickest way to do it. Cool? Now, a dot plot over here, let's kind of look at this over here. The dot plot below shows the amount of points that Kaylee E has scored in the past 15 games. All right. So in 15 games, here's the amount of points that he scored. That means how many dots are there total? You don't count it. I guess just tell me based on the information I've given you so far. How many dots should there be? There's 15. Exactly. Erica, here's what you do. Okay? Go on your computer, download stats, the PDF for Stats 1. You probably did already. I'm on page 4. Okay? Also, let me share this link with you so when I refer to the spreadsheet, you can just go straight to the spreadsheet. Here's the link. Got it? You can do the same as well, Savannah. For now, I'm on the PDF, page 4, okay? But yeah, exactly, Savannah. Yes, there's 15 dots. I mean, I guess you could count them, but each dot should represent a game, and this is how many points he scored. All right, what is the least amount of points that Kaylee has scored in the past 15 games? Looking at this picture on page 4 of the PDF. 9. Awesome. You can look at that and immediately, boom, I got it. How many points has Kaylee scored with the greatest frequency? I'm asking you question C. Come on, Savannah. This is actually probably more for you. This is what I wanted to ask. How many points has Kaylee scored with the greatest frequency? If you don't know, say IDK. All right. Kaylin says 1. No, not 1 point. 12 points. There we go, Erica. Yeah, exactly. If you look at this thing, the number that has the greatest, it means that, like, I'm looking at this and I say, oh, okay, so there's 4 games, because each dot represents a game, where he scored 12 points for that game. So the greatest frequency that he has is 12 points, because there's 4 games where he does that. Does that make sense to you? How many games did he score over 15 points? Question D. 2. Yeah, because you have 15 points here, 17 points here. This is one game. In one game, he scored 19 points. I guess he was doing really well in these games. All right, here, I got a question. Would you predict that Kaylee will score 17 points in his next game? Do you think that his next game is going to be 17 points? What would you say his next game would be? About 12? I agree with you. I mean, you look at the graph and you say, well, in 4 games out of the 15 he's played, he's scored 12 points. That's the most that's the most often that comes up. So it's probably going to be there. I mean, he could score up to 19, but obviously that's a lot less likely. Or he could score as low as 9, and that's a lot less likely. He's probably going to score about 12 points. All right, cool. So you guys know how to read dot plots then. Which actually, to be honest with you, I kind of probably glossed over too quickly, and I assumed that you did. And by judging based off of your answers, it didn't seem like you all were comfortable with it before. Are you comfortable with it now? All right, cool. So the next thing I need to introduce to you is these things called histograms. Now, look at all of this data over here. All right, all right, let's see. Let's say that instead of how many hours they spent on Facebook or Instagram, we reported the data in the number of minutes. We wanted to be more accurate. We didn't want to just say 3 hours. We wanted to say 360. Wait, 180 minutes. I don't know, for some stupid reason. We reported, actually not stupid reason, it actually makes sense. For some reason we want to be more accurate as to exactly how much. I'm on page 6, I think. Yeah. So we want to be more accurate as to how many minutes they spent on Facebook or Instagram, so we reported the minutes and whatnot. So what we're going to do is we're going to do these numbers over here. Did I even put these numbers in? Oh yeah, I did. All right, so I have my numbers, and I just copied and pasted. I didn't copy and paste it. I just typed in my numbers. So I took this little data, these tables over here, oops, and I said, all right, I'm going to put all my numbers in there. So here's the table, and I put in all my numbers. Are we cool with that? Now, I guess the idea that I'm going to do now is I'm going to say, all right, let's see if this works. I want to, organize them. So I'm going to go sort A to Z. So all I did was I basically took this seemingly random, group of data, and I put it in order from 0 to whatever. Are we cool? Now, what I don't want to do is, I think it would just be a sloppy table if it looked like that, where if it looked like, if it looked like this would be kind of an ugly table for me, right? And what this is this is exactly the dot plot that we had last time. There's a bin for each number. Do you guys agree that this is not necessarily that cool looking? It probably doesn't even help us very much, you know what I mean? So what I'm going to do is I'm going to say I don't want a bin for each minute. So how many people were exactly at 100 minutes? How many people were exactly at 110 minutes? And that kind of stuff. What I want to do is I want to do a kind of a range where I want to say I'm going to cluster all the people who are in the hundreds area. So, here I want to cluster all the people that are between the number 100 and 149, or 100 and 150, not including 150. You see what I mean? So what I'm going to do is I'm going to say I want the graph to show me the number of people between 100 and 150 is 4 people. 1, 2, 3, 4. So there's a way to do this, but I found that the easiest, quickest way probably for you guys to understand too is to just go do advanced edit. You want to advanced edit the histogram that you're working on, and then you want to make the bucket size to be 50. There we go. So there are 4 people that use between 100 and 150 minutes, not including 150, according to my table. There's 1, 2, 3, 4. Are we cool? Now make sure you guys know how to do this, because you guys need to be able to create your own histograms and, not Instagram, but histograms. Are we cool? Yes? No? Come on, talk to me, folks. I want to hear your beautiful voices that are typed through a computer screen and I never actually hear your voice. So then basically I go through and I can plot this thing. And you can make this histogram on your own, or you can have the computer do it for you. I, for one, am actually preferring to teach you completely to do it through the computer. I'm not even going to write anything down for probably the rest of the year. I'm just going to teach you through how to use the computer to aid you in all of this kind of stuff. So we can easily see it. By the way, I have no idea why there's no vertical line right here. There should be. But you can see that between 200 and 250 minutes, there are exactly 6 people that use Instagram. And there are exactly 6 people that use Instagram between 250 and 300 minutes. So that's what my graph looks like. We cool? And then you can answer the same questions, like what interval is the least frequency? Which one, in other words, what is the time that the least amount of students spend on Facebook and Instagram? Look at you don't need to look at the numbers. I want you to look at the table. That is not an answer. Sorry. Weird though. Erica's post came in at 9:37, and then Kaylin's post came in right after that, which is at 9:36. Huh. Still weird. Anyway, looking at my table, I'm actually at the second tab, Erica. I don't know if you could see which one I'm at. Go to the bottom tab of that spreadsheet that I gave you, and look up, or just click on the tab that says histogram. All right. What interval of time is observed that has the least frequency? I need you guys to respond because I guess I'm introducing you to new topics, so I mean it's important that you guys understand this. Yes, exactly. Between 350 and 400. Perfect. All right. I would do a question about this, but this is actually really similar to dot plots. The only difference is with a dot plot, you put a dot for each number. With a histogram, I kind of look at it as you know how I keep saying the word bins, and I don't know if you guys understand what I mean when I say the word bins. I guess I kind of look at them as like buckets. This is the bucket that holds all the numbers between 100 and 150. So all the numbers between 100 and all the way up to 149. This is the bucket that holds the numbers between 150 and 200. This is the bucket that holds between 200 and 249. You know what I mean? And then basically, how many numbers am I going to put inside that bucket? So I'm basically making the buckets bigger. Do you guys understand what's going on here? So this graph to me is actually much more useful than the previous graph that I showed you where I had it look like a dot plot. Are we cool? Savannah, can you still hear me? All right, just making sure. All right, cool. So I'm not going to go over this histogram example, even though I probably should. I think I gave this to you as homework, histogram number 2, so I probably should go over histogram number 1, but I have 20 more minutes that I want to cover box and whisker plots, and those are kind of weird. So if it's all right with you, let's jump over to those. Cool. What is sheet 8? Interesting. All right, box and whisker plots. Let's see. I don't have my computer that has the pen tablet broke on me, so this one's going to be a little interesting to show you guys how to do. First thing I want to show you guys is, do you guys know how to find the average of a number? That's my question. All right. Well, good, because you would not believe how hard it is for my Algebra 1 students to find the average of a number. How do you do it? How do you find the average of a number? Erica and Savannah, can you do me a favor? Can you turn on your microphones? That way I can feel like I'm talking to you. Because then I'd actually be talking to you. If that works. Anyway, if you can turn on your microphones, please do so. I want conversation here. Anyway, yes, you're absolutely right, Erica. You add the numbers together and divide by the number of numbers. Yeah, it's a little bit weird to type out and write or even explain, but yeah, that's it. Does everyone know that, where you, like, if you're given two numbers, you add both those together and you divide by 2? because you added 2 of them together. If you're given 3 numbers, you add all 3 of them together and you divide by 3. Cool. That's wrong. Erica, it was kind of a trick question. It actually wasn't. If I ask you to find the average of something, now we're going to talk about this later on in next chapter. So on Wednesday, I'll probably want to spend 2 hours, and I'm probably going to cover 2 chapters with you, 2 sections of statistics with you. But there are 3 different types of averages you can find. If I ask you to find the average, the question that you need to, the answer that you need to give me is actually a question. It's almost like if I told you to jump, what you should do is you shouldn't jump, you should ask me how high. You know, you've heard that expression? No, it's not weighted averages. That's a different thing altogether. But there are 3 different types of averages. One is called the mean, one is called the median, and one is called the mode. Next chapter, I'm going to explain to you what the median and the mean and the mode are. But actually, in this one, we're actually talking about the median of a number. No, the median is an average. In fact, in some cases, it is a more accurate average than the mean is. And I think it's really interesting to look at, well, why is that the case? What's going on there? I'll cover that with you on Wednesday. But the median is technically an average. Now, granted that normally when somebody asks you to find the average, they most of the time mean find the mean, M-E-A-N. But technically, what you should ask is, you know, yeah, exactly. Usually, when people ask you find the average, they almost always find the mean. So technically, if I were to ask you find the average, then well, not technically, but I mean, if I were to ask you to find the average, usually what I'm asking you to find is find the mean. Add the numbers up, divide by the number of numbers you added. But technically, what you should say is, well, are you asking me to find the mean, the median, or the mode? Now, when we're doing box and whisker plots, what we're looking for is the median of things. So here's how you find the median. I'll show you. Okay? What we're going to do is we take a list of numbers, and you know what? I'm going to put that list of numbers right here, just so I can mess with it. By the way, go to the bottom. There's a part called box and whisker. I'm going to take that list of numbers. I'm going to do this. I'm going to copy and paste it over here. Actually, you know what? I'm going to copy and paste it down here. I'm going to mess with it down here. So what I can do is, and you won't have a Google spreadsheet when you're actually doing a test. So if they ask you to make a box and whisker plot, or more likely they'll ask you to read a box and whisker plot, this is how you do it. You take their list of numbers and you put it in order. That's always the first thing you might want to start with. Why is it always doing this weird stuff with me? Okay, wait. Let me just delete this. All right. I copied the numbers. Let me just make a new spreadsheet. I'll remake this thing. Okay? All right. I want to sort the data. All right. So I sorted the data from smallest to biggest. It's the same numbers. I just put it in order. Are we cool with that? Now what you want to do is you want to find the median. And all the median is it's the middle number. It's the number that's in the middle. So if there's an odd amount of numbers, like in this case there's 15 numbers, that's actually nice because there's exactly one middle number. One way that I do it is I just kind of like, you can like cancel out. You cancel out this one, you cancel out this one, and then basically find whatever the middle is. In this case, what the middle is 8, right? Or it's the 8th number, because there's exactly 1, 2, 3, 4, 5, 6, 7 over here, and there's 1, 2, 3, 4, 5, 6, 7 over here. So in this case, the median is Are we cool? All right. So what you want to do is you want to find the median, which is basically the middle of the numbers. Yes, exactly, Erica. Now, if I added another number up here, like maybe 39, let's pretend that I changed my data, okay? Then there are 16 numbers. You see, there's a 16 right there. There's 16 numbers. So the middle is actually, you can't really tell. Like, there's no middle because it's an even set of numbers. The middle would be in between the 8th number and the 9th number, right? So all you do is you find the mean of this. So your median is 15.5. If there are an even amount of numbers, then the median is the mean of the two numbers in the middle. Does that make sense? And by mean, I mean the average. Actually, I shouldn't say that because if I told you the average, it could be mean, median, or mode. And I'll tell you the difference between the two. Are we cool with that? One way people like to do it to keep track of things is they basically take the thing, put it in order from smallest to biggest, and then I do this too, is I just cross off one number here, one number here, one number here, one number here, and I just kind of work my way till I get to the middle. If I have two numbers in the middle, that means I have an even data set. Then what I do is I just say, okay, well, it's, you take the average of those two numbers. I'll tell you the easiest way to do things. You want to see it? Here's the cheater's way. And it's not the cheater's way, because remember I told you I would teach you using spreadsheets. I would say equals median, parentheses, grab the data that I want, close parentheses, press enter, and Google's thinking about working with me. I don't know why enter didn't work. Enter. There we go. 15.5. So it tells me the median based off of, the thing. So I had Google calculate out the median for me. I didn't have to think anything. Are we cool? Now when I deleted that thing, that made up number that I had at the end, then it was it would be it would be 15 because there's an odd set of data. Yeah, everything. All right, cool. Okay, so the median's pretty easy to find. All right. Now, if I'm asking you, when we do box and whisker plots, there's another piece of information that we want to find. What we do is once we take our data and put it in order, we can break it into two parts. We can break it into the lower half and the upper half. We good with that? Here's the lower side, here's the upper side. So what I can do is I can find the median of the lower side equals median of just these numbers. And apparently that's 10 in this case. And I can also find the median of the upper side equals median, parentheses, just grab all of these numbers, close the parentheses, enter, equals 18. So the median of all of them is 15. The median of the first half is 10, and the median of the second half is 18. Are we cool? This number right here, this number 10 right here is called the lower quartile. Got it? This number right here is called the median. It's also called, it's just called the median. And this number right here is called the upper quartile. The upper quartile is just the median of the upper half. The lower quartile is the median of the lower half, and the median is the median of the whole dang thing. I guess if you want to think about it, like, if this were halfway, then half, you know what I mean, then halfway between that is 1/4 of the way. So we call this quartile 1. And this one would be quartile 2. And here is quartile 3. Huh. What do you mean quartile is 10? What are you talking about there? Or I mean, is 12. What do you mean by the number 12? Erica. Yeah, 18. Okay, good. Huh, I was worried there for a second. Yeah. The upper quartile is 18. That it's basically like 3/4 of the way there is 18. 2/4 of the way there, which means halfway, is 15. And then 1/4 of the way there is 10. Are we cool? So what we do is we make a number line, all right? We make a little number line like this right here. It's just, a line with numbers. And we'll put a tick mark at 15. We'll put a little mark at 18, and we'll put a little mark at 10. And then what we do is we draw, let me look up a graph for box and whiskers. I'll show you what it officially looks like. I don't know how to draw box and whiskers using a spreadsheet, but I figured out a very clever way of doing it. Okay, this is what a box and whisker plot looks like. Okay, this isn't for the data that we have, and I don't have my pen, so I can't use it. But what we do is we draw a little mark right here at the median. We draw a little mark right here at the lower quartile, and we draw a little mark right here at an upper quartile, and then we put a box around the whole dang thing, and we'll put a little line right over here at the median. Are we cool? This is the box. Now, these whiskers, I guess it kind of looks like a little cat that has whiskers. This is actually really easy to get. This number over here, the upper extreme, all that is it's the biggest number in your set. So our upper extreme is 37. And our lower extreme is 5. We cool? So there's 5 numbers that we need to talk about. Technically, there's also a term that you probably don't know, and it's called the interquartile range. The IQR, interquartile range. All that is it's the upper quartile minus the lower one. Basically, it's the space between this top box and that. I mean, it's the size of the box. That's all it's asking. What is the size of the box? The IQR. And you just take whatever that number is and minus that number right here. So in our case, it's 18 minus 10, which is 8. I mean, of course you knew it was 8. Are we cool? Savannah, Erica, Kaylin. Awesome. Now, I feel like you have a very valid question to ask me. And that question is, well, why the heck should I learn this? Why do we make this box and whisker plot? And I'll be honest with you, I've done science, and I've done lots of science, and I don't think I've ever done a box and whisker plot in science. I mean, I've done dot plots, and I've done histograms like nobody's business, but I've never done a box and whisker plot. So why should we learn this? You know what I mean? I don't know. Do you guys have the same question, or you guys just be like, I don't know, I'm going to learn anything you tell me, Mr. Daldy, because I am a mindless robot. And you are so awesome and amazing that I will believe you and anything you say, and I will follow you off a cliff if you say jump off a cliff. Alright. Yes, I really don't understand why I'm learning it. It helps visualize and understand it. Erica's absolutely right. Savannah, you're absolutely right too. Let me tell you kind of what the idea is, and I think that this actually has more with people who are going to be dealing with statistics more, but it actually is really interesting. What it is it helps you look at data and immediately draw conclusions off of it. If you see this median right here, or like you look at this lower extreme right here, and this lower quartile. Look at how this whisker on the left is bigger than that whisker on the right. That tells me that there is a bigger gap between these small numbers than there is between the big numbers up here. It tells me also, this thing tells me that, like, look, the median, look how much further the median is from this side. I mean, like, here's the lower extreme, here's the upper extreme. So the lowest part of the data is going to be somewhere around like 18, and the highest part of the data is going to be somewhere at 100. But the median isn't exactly in the middle. It's kind of shifted off more towards the right. This tells me that the data, there's more people on the higher side than there, not more people on the higher side, but they're the higher side, I guess, has higher numbers. I mean, of course that's true, but this tells me that the middle piece of the data is actually not exactly in the middle between 100 and 18. It's, you know, a little bit shifted off to the right. These kinds of things, these kinds of conclusions that you can draw upon by looking at this thing immediately is really useful. And I'll be honest with you, it might not be as useful to you, Savannah, because I don't know what you're going to go into. I don't know what you're going to study as a student. I don't know what you're going into, Erica, but I think it'd be good for the general population to at least be introduced to box and whisker plots, so that if you see it, you won't be a complete bumbling idiot. So what it does is it helps you visualize all of this stuff quickly. You can look at this and be like, oh, I get it. I see what's going on. That's what a box and whisker plot is. Now I'll show you what my box and whisker plot looks like. It doesn't exactly look like theirs, but I thought it was a very clever way of coming up with it. This is what I came up with it. And by the way, you can always go to File. When I share this thing with you, you can always go to File, make a copy, and you can make your own copy, and then just plug in the different numbers into here, and you'll have, look, a box and whisker plot. I made one. Here's the median at 15. Here's the lower quartile at, what was it, 10 or 12? I don't know. At 10. Here's the upper quartile at 18. Yeah, that's right there, at 18. Here's the upper part of the data, here's the lower part of the data. And our box and whisker plot, and the gray part is the box, and I couldn't make these whiskers any nicer, but here's the whiskers. I couldn't make them darker. I wish I could make it all in black. Anyway, cool, Mr. Data. Mr. Daldy. That's pretty cool. Box and whisker plot. And I'll show you the secret behind it, really, is there's a bunch of numbers that I had to calculate out, that I had the spreadsheet calculate. And if you look over here, you don't see anything, but I'll show you. You're going to be like, wow, that's actually kind of interesting. There are a bunch of numbers that I had the computer calculate out for, and then it plotted those numbers. But then I just hid them from you guys because I didn't want you guys to have to worry about that. So that's my secret that I use for this box and whisker plot. So you guys can always copy and paste this, your numbers into this thing and get your own box and whisker plots. Are we cool? So I ask you to make a bunch of box and whisker plots and take a look at it. All right, let me see if you guys can read a box and whisker plot. Take a look at box and whisker plot number 1. All right. What is the smallest number in this data set? What is the smallest? This is represented by a list of numbers, and I can represent it as a box and whisker plot. What is the smallest number? 10. Perfect. What is the first quartile? What is the lower quartile? 13. Absolutely. What is the second quartile? Oh, I'm sorry. I'm looking, Erica, I'm looking on the spreadsheet, or on the PDF, and I'm on page 20 already. I'm doing box plot number 1. Exactly, Kaylin, it's 16. The second quartile is basically the median of the whole dang bunch. That's 16. What is the upper quartile? This is quartile number 3. 19. Perfect. What's the inner quartile range of this box and whisker plot? Well, it would be 19 minus 13, so that's 6. Yeah, absolutely. Very good. Awesome. That's it. And that's all I really have to teach you about box and whisker plots for now, because in Algebra 2, unless you're going into statistics, I'm sure that you'll get deeper into this, but in Algebra 2, I really just want to introduce it to you. There's a lot of terminology, and there's a lot of like hoops that you jump through, and you just do it. You just jump through these hoops, and you say, okay, well, that's what's going on. I don't think that we're going to ask you to draw like conclusions or extrapolate ideas or data from these box and whisker plots in Algebra 2 Introduction to Statistics. I think that you'll get that when you take like a statistics course, which I've never taken a statistics course, so maybe that might be why I've never actually used these box and whisker plots. Are we cool? So that pretty much covers your homework. I want you guys to come on Wednesday, and I need to send out an email saying, get you guys' butt in class, because I'm really kind of dwindling on my attendance. I need you guys to get to class because we need to make sure to cover statistics. But Erica, we're going to talk about the difference between mean, median, and mode, and why there's 3 of them. What the point of having 3 different ones are. I think it would be an interesting discussion that you would be very interested in. So, yeah, let's go from there. All right. Anyway, I'll talk to you guys later. It was wonderful to hang out with you guys. So what is due this week? Technically, all the stuff that I had due on Friday, I was actually going to make that due this week. So I'm going to post the homework for Stats 2. I only finished posting the homework for Stats 1. Let's see. I only finished posting the homework for this one. I need to post the homework for Stats 2. Mean and standard deviation are actually going to be really important topics for us to cover. I don't know if I will get to stats 2 and 3 by next week. Actually, or by tomorrow. Actually, I probably should. I need to cover stats 2 and 3, and then cover stats 4 and 5. And that's, I think, all we'll get up to before our... I want to try to finish that before the EOC test. And then after the EOC test, we'll finish off this idea of exponentials. We've taken a break from exponentials and gone into statistics. Erica, I'll read all of your emails and try to fix all of the stuff that is wrong in stats. I apologize for any mistakes that I made. It's actually kind of hard to come up with these questions. Yes, we will cover Expo 7 and Expo 8, 9, and 10, whatever. But I didn't... But I felt like if I did that and didn't make this jump, I wouldn't get to it by the time we have the EOC comes up. And I feel like you're going to see the stats on EOC, so I wanted to make sure you guys were at least introduced to statistics. We cool? All right. Talk to you later. Goodbye. Always good times to hang out with you guys.